a major bond exception called hybrid orbitals. I think the easiest way to go over it is just to use examples. The first example I'm going to give you is beryllium. Here. What group is beryllium in? Group 2. So its valence is 2. So if we were to write beryllium as an electron dot diagram or a Lewis structure, how many dots? 2. Where would we put them?
Right
Yeah, like right here. In general, we said that element X would have the S's here, P, P, and P. Here's the problem. This is the ABCs of bonding, but this is the reality. Beryllium, when it bonds with, let's pick fluorine. What kind of molecule is that, shape-wise? Shape-wise. Nonpolar and linear. Can that produce that? They on the same side? So wouldn't you expect one fluorine here, one fluorine there? In other words, this doesn't explain what really happened. So we needed to modify our theory. So instead of having the typical S and P orbitals, we're going to do what's called a hybrid. What does hybridization mean? Mix them. So we have hybrid vehicles, right? Gas, electric. We have all kinds of hybrid animals, all kinds of hybrid plants to increase productivity. Let's take a look here. If I drew the electron configuration, beryllium's in row 2. So the valence would be 2s, and there are 2 electrons. And that doesn't work. You can't get this configuration from that. So watch what happens. There's another way of doing this. If we start with an s orbital, which is no problem, what would be the next one? What's the next valence sublevel? P. Okay, how many electrons do I have? 2. So I'm only going to deal with 2 orbitals as well. 1 orbital for each electron. S, the next valence would be P. You know, we know there's possibility to have up to 3 orbitals, correct? But we only have 2 electrons to work with. What happens if we take these and we hybridize them? See how there's 2 here? We're going to mix them. So they're both going to be sp. They're going to be called sp orbitals. And let's put an electron in each. Now, if we do that, we call this sp and this sp. This is the new explanation for how that bond actually happens. Let's try boron. Boron is in what group? Group 3. So how many dots? Because it has 3 valence. Where would we put them traditionally? 2 here in the S, and 1 somewhere else. We'll put it on the top. Watch the bond for boron. It bonds like this. That is called trigonal planar. Instead of 3-dimensional like the tetrahedral and the pyramidal shape, it's really only like 2-dimensional. It's all in the same plane. So it looks like a triangle, trigonal. And planar means same plane. Take a look at it. This is what really happens. Can you get that from here? No, our simple bonding doesn't explain it. So we have to change our explanation. Let's do the same thing. This would be, watch this, 2s, and there'd be 2 electrons there, and then 2p would have 1, correct? That's what the traditional would be. We have 3 electrons, so let's play with it a little bit. S, and take a guess how many p's we'd use. We know p can have up to 3 orbitals, but we only have 3 electrons to work with. Then we're going to mix these. We're going to hybridize them. So they're all going to become sp2, right? Because there were 2 of them. sp2. sp2, and you put an electron in each. That allows these to become sp2, sp2, sp2. Carbon is in what group? 4. So what's its valence? 4. How many dots? 4. Go 1, 2, 3, 4, correct? Watch how carbon bonds. You remember. And we call this tetrahedral. Yeah. Can this produce this? There's no way this can produce 4 equidistant bonds. If we hybridize it, watch what happens. This time we will write, this over here would be 2s, and then you got your p sublevels here. You only need 2 of them here, see? So now let's hybridize them. 4 electrons, look, we use the s, and all 3 p's. So guess what it's called?
2p.
So let's do it again. S, 3 p's, right? There they are. Now we're going to hybridize them. How many p's?
3.
So guess what it's called?
sp2.
sp3, sp3, sp3,
sp3.
sp3. Put an electron in each. Just a valence. Now you can get an equidistant bond. This is an explanation, folks. This is a theory showing the tetrahedral shape. You can see how it grows here. sp, sp2, sp3. They are hybrid orbitals.